Welcome back everybody. We are looking at differentiation. This is the first of many videos on differentiation here. And the first thing we need to clarify is that make sure that your ability to differentiate is quite high before you move on to the applications of differential calculus. Otherwise, it'll just be chaos. Promise me. So having a look at our log tables here, we can see there's loads of differentiation rules there for us to use. And just a quick tip, if what you have doesn't match up to what's exactly in your log tables, we're going to use the chain rule. Now we won't be doing the chain rule in this video, but it will be the next one. So make sure you subscribe and hit the bell so you don't miss that. So let's move on to our first example. We have the function 6x squared plus 5x minus 4 and we're asked to differentiate it. Now it's three separate terms there. We use our rule on the top left hand corner of the page and we bring down the power, reduce the power by 1. We get 12x plus 5. Moving on to example 2, we got 6 minus 3 over x. Now, that 3 over x needs to be written as 3x to the minus 1 because it's easier for us to implement the rule then. So what we do is we differentiate it, again, work with the fact that there's a minus. We get 3x to the power minus 2 and we bring that x to the minus 2 underneath the line and becomes x to the positive power of 2. You can clearly see rules of indices have a big impact on differentiation. Moving on to example 3, we have some surds in here, and again I'm showing you these examples for a reason. We don't differentiate surds, we differentiate powers. So we need to rewrite the square root and the cubed root with the power of a half and the power of a third. It's super important that you don't let the powers and the surds and the fraction situations put you off. You rewrite it using your rules of indices and then you use the most straightforward rule possible, which is the one we are using here. And it's good policy to try and give back the answer in the same form that it was given. So we revert some of those values back to a surd there. It's very important to remember on that note that when we differentiate, we're doing a job. Differentiation has a purpose, and again we see that in the applications part. So they're not always the most beautiful things that you're going to see. You just need to get the job done and write it in its lowest form. That is all the ordinary level differentiation that you have to know, but we are going to move on to more examples which include the product rule and the quotient rule, which are more for the higher level students. I already hope that you know the product means to multiply. So when you have a function where there are things being multiplied by each other, instead of actually just multiplying it out, we're going to use something called the product rule. Again, it's on that page in your log tables and you identify the two pieces being multiplied as u and v. And then you differentiate the u and you differentiate the v. So you can see me doing that here. The formula to solve it and get dy dx is essentially u dv dx plus v multiplied by du dx. So I simply just follow that and fill in that information as you can see here. It's really good to write all these bits and pieces out so it's very clear to see. Your indices rules are going to be super important here, but stick to the basics of multiplying things out. So I multiply out those brackets bit by bit. I take my time, and don't forget it's perfectly okay to use your calculator to check that you've done the right powers and they have the right signs and things like that. This actually reduces down really nice once I implement my rules of indices and work it out, and I end up getting a value of 1. Happy days. Don't hesitate to stop and rewind this as you're going through these examples so you can practice them. Our fifth and final example for today is f of x is equal to 3x plus 2 over x squared minus 3. This is a fraction. We've x's above and below the line, so we're going to use the quotient rule here. Again, it's on that page in our log tables. I have the top of the line as my u, the bottom of the fraction is my v, and I find du dx and dv dx there, as you can see. So to build it, we've a little bit more to sub in here. So I have v du dx minus u dv dx all over v squared. So you just sub in the bits and pieces that you're told to sub in. And yes, more multiplying out. This one doesn't have any fractions in the power, so it's a bit easier for us to multiply it out. And you multiply it all the way out. Some people don't multiply out the bottom line, some people do. I did in this case just to see was there any more opportunities to simplify down, but it doesn't matter if you do or you don't. And you make sure it's as tidy as possible. So again, we do get a big old lump of a fraction here at the end, but again, remember, calculation like this has a purpose in the applications of calculus. Again, there are plenty more differentiation videos to come, so make sure you subscribe and hit the bell for the next one.